Hello, so I'm going to explain problem 4 of MEXT Physics 2017 Undergraduate. So the problem is 1 mole of an ideal monodic gas is taken through this cycle from A to B to C to A again, and it said that B to C is an isothermal process, so the T here is equal to the T here. The T in B is equal to the T in C, in which the gas absorbs the heat Q0. So this process absorbs the heat of Q0. Well, that is as our answer the following questions. So the theory that you need to know to solve this thermodynamics problem is that the Q absorbed is equal to the change of the internal energy plus the work done by the gas, and the change of the internal energy for a monatomic ideal gas is that 3 over 2 nr times the change of the temperature, and the work done by the gas is the integral of pressure in respect to volume. And we should also know that PV is equal to nRT, and when we move T to here, so it became PV over T, and since nR is a constant, we know that PV over T is constant, so the P that is at some point before, the PV over T at some point before, and the PV over T at some point after is always the same. The magnitude is always the same. So we work on number 1. Find the temperature of the gas at A. So we can use PV over T for this, since PV over T is constant. So we could take any point you want, whether it is B or C, but let's choose B. But you can choose C, but it's going to be same. So the P of B is 3P0, so we write 3P0, and the volume is P0, and the temperature is T0, because the temperature at B and C is both T0, is equal to, at point A, the P is P0, and the volume of A is V0 over the temperature of A, and we can cancel P0 and V0, so we get TA is equal to a third of T0, and the answer is B. Number 2. Find the heat absorbed by the gas in the process A to B. So from the theory we know that the Q absorbed is the change of the internal energy plus the work done by the gas, and this equation becomes this, and since the process A to B, it has no change of volume, the integral of PdV is 0 because there is no change in volume, and so we can just write the Q absorbed is the change of the internal energy, and it's equal to 3 over 2 nR, the change of the temperature, and the change of the temperature is T final minus T initial, and the T final is TB, which is T0, and the T initial is A, and we know from number 1 that TA is equal to a third of T0, so we can calculate that T0 minus a third T0 is equal to 2 over 3, and 2 over 3 times 3 over 2 is 1. So since N from the problem is that it is 1 mole, so we can write N is 1, so it doesn't affect anything, so we can write RT0. So the answer is F. Number 3. find the work done by the gas in the process B to C. So as usual, we write Q in is equal to delta U plus W out, and we write delta U as relative to NR change of the temperature, and we don't need to write the work as integral PDV because the question asks us to find the work, so we don't need to change this. And the gas in the process B to C, it is isothermal, so there is no change of temperature, so delta T is 0, so this whole delta U is 0, so we can write work from B to C is equal to Q naught, and the answer is I. Number 4. Find the work done by the gas in the process C to A. So since P is constant, we can write integral PDV as P times the change of the volume, and the change of the volume is the V final minus V initial, that is, the final is VA and the initial is VC, and we know that the VA is V naught and C in VC is 3 V naught, so we can write V naught minus 3 V naught, and 1 minus 3 is 2, so we can write minus 2 V naught, but in the answers we are asked to find in terms of R of R and T, so we can use PV is equal to nRT, and let's use B here to find the nRT. So at point B P is 3 V naught and V is V naught, and is equal to nR. The temperature of B is T naught, so we're going to find that P naught V naught is equal to a third of nR T naught, so we can write P naught V naught as a third of R naught T naught, and N is equal to 1, so it became like this. So a third R naught T naught times 2 is minus 2 over 3 R naught T naught, and the answer is C. Number 5. Select a correct relation for the sign of the network W done by the gas and the net heat Q absorbed by the gas per cycle. So from this equation, for delta U for one cycle, think that U here, U final here, is equal to the U initial, so it's right from UA, and for one cycle it returns to UA again, so the change of the initial energy, the change of U, is none, so we can write delta U is equal to 0, so we can write Q absorbed is equal to W that is done by the gas, and since W is the area of the graph, so integral PDV, so let's say A to B, so the integral PDV is done from A to B, but from B to C is the area here, the area under the line from B to C to the line of V, and from C to A it's subtracting the area under line of C to A, so we are left with this triangle-ish area, and because the triangle-ish area is still positive, so the area exists and that is positive, then the W is positive, W is more than 0, and because Q is the W itself, Q is also greater than 0, so the answer is A.